In this video, we're going to take a look at solving rational equations using a common denominator. So in this question, it says solve, and then we have 2x plus 1 over x squared plus 4x plus 4x over x squared minus 3x equals x plus 9 over x squared plus x minus 12. Now, the previous method, or method number 1 that we talked about, was solving by cross multiplying. You can cross multiply if you only have one rational expression on the left and then one rational expression on the right. As soon as you have more than one rational expression on any of the sides, you are going to need to find a way to combine them by getting a common denominator. So I will need to add these two fractions together before I can cross multiply. But I am going to say up front, if I need to get a common denominator, then I will actually do it for the entire question instead of just doing it for the one side. It will end up being less work in the long run. So the first thing that I would do is I would move all of the fractions onto the same side and then get a common denominator. So I'm going to move that x plus 9 over x squared plus x minus 12 to the other side by subtracting the fraction. So this is going to be 2x plus 1 over x squared plus 4x. And then I have plus 4x over x squared minus 3x. And then we're going to subtract x plus 9 over x squared plus x minus 12. And then because I have brought them all over to the same side, that means this other side is now equal to 0, which is something that we often look for when we are trying to solve an equation. All right, so if I want to combine these fractions, we are adding, we are subtracting. I do need a common denominator. However, looking at these denominators, it is difficult to tell what the lowest possible common denominator might be. So we are going to start by factoring our denominators to see what multiplies into each one, and then that will allow us to get, hopefully, the lowest common denominator. I am not going to factor the numerators. We're just focusing on the denominators right now. So I have 2x plus 1 over, and then this has two terms. I could factor it off to the side, but I do notice that they have a common factor of x. So I'm just going to factor out an x, and I'm left with x plus 4. Right, plus, numerator is going to stay the same. It's 4x. X squared minus 3x. I'm looking at that denominator. I see that there's two terms, and they both have an x. So I'm going to common factor out x to get x, take away 3. My third one, I'm leaving the x plus 9 alone. And then the x squared plus x minus 12, I am going to take that over here to the side where I have a little bit of space. It has three terms. They do not have a common factor. We've got x squared x and a number, and there is no visible coefficient other than a secret 1 here in front of that x squared, meaning I can use the trinomial shortcut, or you can use decomposition. I am looking for two numbers that multiply to negative 12 and add to that middle term of 1. So that would be positive 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is positive 1. All right, because there's nothing in front of that x squared, that is just going to be x plus 4, x minus 3. Okay, that is my last denominator, x plus 4, x minus 3. And it still equals 0. Okay, I now want to see if I can figure out what the lowest common denominator would be. So I'm going to start with the first fraction. And when I do this, I like to just make one gigantic denominator. I find it's a little less work in the long run, but it's up to you what you want to do. So for the first denominator, it needs to have an x, and it needs to have an x plus 4. If I look at the second fraction, it needs to have an x, which I already have, right? Because we needed one for that first fraction, but it also needs an x minus 3, which we don't have yet. So we need an x minus 3. If I look at my third fraction, it needs an x plus 4, which we have, and an x minus 3, which we have. So our common denominator is going to be x times x plus 4 times x minus 3. Now, what we need to do is adjust our numerators for whatever it is we've done to get our denominator. So I have x times x plus 4 on that first fraction, and what we're missing is the x minus 3. So I need to multiply the bottom by x minus 3, which means we also need to multiply the top by x minus 3. So we're either doing 2x plus 1 times x minus 3 or x minus 3 times 2x plus 1. All right, and then we have plus, so we're going to do our plus sign. Here we have x times x minus 3. The part that we're missing is the x plus 4. So I'm going to multiply by x plus 4 on the bottom and x plus 4 on the top to make that equivalent fraction. Now, I like to put the monomial first if I have one, so we are doing 4x times x plus 4. All right, then we are subtracting. Last one, we've got x plus 4, we've got x minus 3. The part that we're missing is the x. So we are going to multiply by x. Now that is a monomial, it has one term, so I'm going to put it in front. I'm going to do x times x plus 9. And that still equals 0. Okay, so from here, we are not done adding and subtracting. All we've managed to do is get ourselves a common denominator. We will now need to expand and then collect up any like terms that we have in the numerator. Do I need to expand the denominator? No, and you'll see why in a minute. So for right now, we're going to work on that numerator. We're going to leave the denominator alone. So I'm going to distribute or multiply 2x plus 1 by x minus 3. I'm just going to hit the focus. I don't know if that helped. Okay, so 2x times x is 2x squared. 2x times negative 3 is negative 6x. 1 times x is 1x. And 1 times negative 3 is negative 3. When I go to multiply the next part, we are multiplying by positive 4x. So 4x times x is 4x squared. And then 4x times 4 is 16x. The last one, we are multiplying not just by x, but by negative x. So negative x times x is negative x squared, and negative x times 9 is negative 9x. And we are not doing anything to the denominator. So this is x, x plus 4, x minus 3. And it still equals 0 on the other side. Okay, from here, I'm going to collect up all of these like terms. So x squared, I have 2x squared plus 4x squared minus x squared. Let's see if I can find a way to underline them. So 2 plus 4 is 6, minus 1 is 5, x squared. And then we have minus 6x plus 1x plus 16x minus 9x. So that is going to give me negative 5. And then that would be 11, and then that would be 2. So plus 2x. And I am just going to double check. Yep, I got 2. Okay. Last but not least, I've got my constants, which I only have one. That's just -3. And I still am leaving the denominator alone. And it still equals 0. All right, so from here, we have taken our fractions and we combined them. So I really only needed to combine the 2 on the left, but I figured if we're doing it, we might as well just do all of them because it'll make this next step a little easier, right? We got a common denominator that worked for all of them. We multiplied them by what was missing out of the denominator. We expanded, we collected our like terms, and now we are here. So at this point, we are going to do what we learned to do in method number 1, which is cross multiply. So I would like this not to be a fraction anymore. This 0 on this side is technically over a secret 1. So I am going to multiply 1 by 5x squared plus 2x minus 3. And then we are going to take x times x plus 4 times x minus 3 and multiply that by 0. So 1 times 5x squared is 5x squared. 1 times 2x is 2x. And then 1 times -3 is -3. On the other side, anything times 0 is 0. So that entire denominator is gone, which is why I didn't bother multiplying it out. I didn't bother multiplying out those brackets because I knew that when we cross multiplied it to the other side, it was just going to become 0. I do want to point out that after we got our common denominator, on the next step, we could have multiplied that denominator to the other side to make it 0, which would have meant that we didn't have to write down the denominator. So you could have multiplied it to the other side sooner, but I waited until we were done simplifying that numerator. All right, I now have a polynomial equation. So methods of solving are rearranging, factoring, and quadratic formula. There are 3 in total. So rearranging, I have x squared and x. I have 2 terms with x's, so that's not going to work, which means we are either factoring or using quadratic formula. And I have a feeling that this is going to factor, so I think we might give that a try. I am looking for 2 numbers that multiply to -15 and add to 2. So 1 and 15 are not going to work, but 3 and 5 would. If I did +5 and -3, that would multiply to -15 and add to +2. So this is going to be 5x squared plus 5x minus 3x minus 3 equals 0. First pair, I can take out a 5x and I get x plus 1. Second pair, I can take out a -3 and I get x plus 1. So this is going to be x plus 1 times 5x minus 3. And that still equals 0. So last thing we need to do is take a look at each bracket and figure out what makes each one 0. And I'm sort of out of space, so I'm going to do that over here on the side. We're going to look at what makes x plus 1 equal 0 and what makes 5x minus 3 equal 0. Well, x plus 1, that would be a -1 if I take the 1 to the other side and subtract. And then the 5x minus 3, I would add 3 to both sides to get 5x equals 3, and then divide by 5 to get 3 over 5. So I have 2 possible solutions. One of them is x equals -1, and the other one is 3 over 5. Now, it is always a good idea to just check your original denominators and make sure that putting these in does not make either one 0, because you cannot divide by 0. So basically you're just checking that these are not any of the restrictions of your function, which I will tell you right now, they are not. Okay, so that's it for solving rational equations with a common denominator.